most of the slide here, but I want to just make sure we review, because this is very important. And sometimes these variables are an area that sort of trips up students sometimes. They confuse the different types of variables, and so we want to make sure we have these clear. Okay? So you should probably have most of this written down, but we'll go over here. So variables are just factors in your experiment, parts of your experiment that you could change or measure. And we have the three categories: independent, dependent, and variables held constant. So independent variable, that's the one thing you're testing. I often tell people to remember the I looks like a 1 because the independent variable is the one thing that you're changing in your groups. You know, in our rat experiment we talked about yesterday, it was what? What's that?
Vitamin C.
Yeah, whether or not they got vitamin C. That was the one thing that I had different in my two groups of rats. Right? In the plant experiment we started off with, what was the independent variable there?
There wasn't one until we changed the...
Well, I guess there were too many at first, right?
Yeah.
Once we changed it, what was the one?
The color light.
Yeah, the color of the light. All right, so those are some examples. So it's a thing being tested. A good experiment has only one. And you know, we redid that experiment that we talked about yesterday to make it so that only one independent variable was present. Before that, there was 5 or 6 of them. You can think of it as the cause of the experiment. So if you have two groups and there's only one difference between them, there must be a whole bunch of things that are the same. Okay? Those are the variables held constant. Things that you try not to change. So in that plant experiment, what were some of the variables we had to hold constant once we started going? Ari? The amount of water. Okay. What else, Maya? What's that? The type of plant. Shane?
How long they got, how long they supposed to go.
Yeah, how long they had to grow. Was there one more?
Yeah. Temperature.
The temperature that they were kept at. Yeah, those were all variables that were held constant. And then the third variable is the dependent variable. Sometimes there's one, there may be more than one. But the dependent variable is the data that you collect in your experiment, sort of the results of your experiment. And you don't know it ahead of time. You know, when I set up my rat experiment, I knew how many rats I had, I knew how much vitamin C was going to give them, but I wasn't sure how much they'd weigh at the end. It was unknown. Okay, those are the results of my experiment, the data that I was collecting. That's the dependent variable. I underline the D because if you remember, dependent goes with the data you collect in your experiment. So the I looks like a 1 because it's the one thing being tested. The D for data you collect. That can help you to remember those variables. How about in the rat experiment? What were some variables we held constant? Or we would have to hold constant in the rat experiment? Matt?
Size of the cage.
The size of the cage. What else?
The gender of the rat.
The gender of the rat. What else? Sebastian? How much food they're getting? Yeah, there's a whole bunch of things we would have to hold. What about the dependent variable in that experiment? What would the dependent variable have been? Donovan?
Wait, in the rat one?
Yeah, in the rat.
How much they're gonna weigh at the end?
Yeah, how much they weighed at the end, or how much weight they gained, or how long they were, or how much longer they grew. Yeah, any of those things might have been dependent variables. All right, so we got these. Not bad. All right. The last big thing we need to know about experiments is the groups. You guys told me yesterday, the day before, that you couldn't just have one rat in a cage. Because why can't you just have one rat that you give vitamin C to? Okay?
Because something might go wrong in the test and you wouldn't know for sure.
Okay. That's part of it. Well, what's another important thing? Maya?
That rat might just go really bad.
Okay. That's sort of like along the lines of what Shane was saying, but there's something else. Sarah?
You wouldn't be able to tell the difference.
Because I don't have what?
Yeah, the right
To,
see what's the difference.
okay. What's the main word I'm looking for? Anthony?
To compare.
Compare. I don't have another rat to compare it to. I just have one rat. So you need two groups so you have something for a comparison. Well, we have names for the groups. There's the experimental group and the control group. Have you heard of these?
Yeah.
Yes.
Oh, so this is easy?
Yeah.
I have my rats. Which is the experimental group? Emily?
The one that you're gonna go to.
Yeah, the one that's getting extra vitamin C. Which is the control group?
The one.
Hold on. Raise your hand, please. Robin?
Other rats that you compare the experimental,
Yeah, what were they getting?
they weren't getting
Yeah, they were just getting regular food, no extra vitamin C. They were the control group. All right, so the experimental group has the independent variable. It's something's been changed. The vitamin C, for example. We've altered something about it. The control group is just sort of a test run. It's used for comparison. You don't change an independent variable in it. You just sort of treat it normally. And you always have to have that control group. You need a group for a comparison. So we'll be looking at lots of different examples of experiments today, and in your homework you have to read about experiments. So you're going to have to identify, in this experiment, what were those different variables? Which was the independent variable, the dependent variable? What's the control group? What's the experimental group? Something we're going to do sort of over and over again to make sure that you really understand how to do this. Okay, to conclude here a little bit, you need to define a few words. And I know some of these are reviewed. But when we are making observations, these are words that come into play. So first off, we just said the dependent variable is the results of your experiment, the data that you collect. So what does that word mean? What does data mean? Yeah?
information.
Information you gather. What else? What were we going to say, Donna? You were going to say
I was
something?
gonna say something.
Okay. Shane? Say it.
Information you collected over a period of time.
Okay, information you collected. Oftentimes in experiments, it's going to be measurements you're making. Okay, you may record those measurements in a data table. You may graph that data so you can see it visually as well. Those are all ways of representing and collecting data. We also divide observations into sort of two subgroups, quantitative and qualitative observations. Have you guys heard of these? Some?
I can find this.
You can guess definitely by the words themselves. Quantitative observations. What word does that look like? Quantitative. All right? Quantity. Quantitative observations always include a number. Okay, they're measured and they have a number with them. Then what about qualitative? What word do you see there? Raymond?
Quality.
Yeah, quality. These are observations that don't have a number. They're not measured, they're just qualities. They're made with the senses. finally, inferences. Shane, you know what an inference is?
Sort of like a guess based on the knowledge that you have.
Yeah, it's kind of similar to what?
A prediction.
A prediction or a hypothesis. It's a conclusion that you might make, an interpretation of some observations. Can you be sure of an inference? Not really. Yeah, because it's sort of a prediction, the interpretation of what you see, and sometimes things that you see might be misleading, may lead you to the wrong conclusion. Alright. An example, if you look at a slug that's just sat there for hours, you might infer that it's no longer living. Maybe you're right, maybe you're not, but that's an inference. Can you observe that the slug is dead?
No.
Not exactly. You can see it still, you can see it not moving. You can see it shriveling up in the sun. Right? You might make the inference that it's dead. That's an inference. An interpretation of what the observations you're actually. Okay, let's look at some examples. These are fairly simple. We'll get some more complex ones in a little bit, but this will be okay. So in this one, the mothers of the New Hartford JV football team decided they had it with trying to get the stains out of their sons' uniforms. So they decided, do you have a question on them?
Yes. Wait, no, I'll wait. Sorry, we're getting ahead.
Oh, okay. So they decided to conduct their own investigation of stain removers. You know what stain removers are? Not like the soap you put in the laundry, but like Less oil or stuff you like spray on it beforehand, or like that stick, you know, or a Tide pen, those kind of things. Those are stain removers. All right, so they were conducting an investigation of stain removers. They washed 30 filthy uniforms using spray and wash. They washed 30 equally filthy uniforms with Gain. And then they washed another load without any of these stain removers. Each load was washed with the same washing machine on the same cycle with 120-degree Fahrenheit water using equal amounts of the stain remover. And the mothers then looked at the washed uniforms to see how clean they were. All right, I would like you to answer those 5 questions right now on your paper.
Do we have to write the question or do it in complete
No, you can just
sentences?
write your answer. You don't need to TTQA or anything. You can just write a brief answer. And this is also on the next slide too. There's a, I know why there's a blank one at the bottom, but if you turn over that page, there's actually, it's all written out for you. No, you don't have to erase it over there, unless you're a perfectionist and you want to keep a nice clean white slide there.
Can we just do it here?
Yeah, it doesn't really matter where you do it. Bless you. All right, let's talk about these. All right, so in this experiment, and that's what this is. It's really an experiment, just like we talked about today. People use the scientific method all the time, even if they're not thinking about it in that way. And this is an example of that. So in this case, what was the problem in this experiment? Abby, what did you say? Okay, but we want to phrase it as a question. So what question were the mothers asking? You're on the right track. Yeah, how could they get the stains out of these uniforms? That's the question they were asking. That's the problem. Okay. In this experiment, what was the independent variable? Annika? Yeah, the brand of stain remover. So the question you ask yourself is, okay, what was the difference in these groups? And in this case, the difference was what brand stain remover they were using. How about the dependent variable in this experiment? Chris? What's that? That wouldn't be the dependent variable. Who could help Chris out here? Matthew?
How clean the uniform towels are washed.
Yeah, the data they're collecting is how clean the uniforms were at the end. That's what they're looking at. That's the result of their experiment. All right, give me one variable held constant in this experiment. One variable. Megan?
They washed it in the same washing machine.
It was in the same washing machine. Sierra?
The temperature of the water.
Temperature of the water was the same. Okay. Tanya? The amount of stain remover that they were using? Yep, good. Why did they have a load of laundry that they did without any stain remover? What was the purpose of that? Emily?
To see the difference between the loads.
Okay, true. It served as what? What's the word we want to use? What group was that?
Oh, the control group?
Yeah, it was the control group. The load done without any stain remover was the control group. A group treated normally so that you can compare the others to it. All right, any questions about that? What do you think? Easy? Not too easy? In between? All right, let's do one more example here. Oh, yeah. Anyway. One more example. This is another fairly simple one. A candy manufacturer developed a new candy called Zing. The developers could not decide on a color for the wrapper, so they decided to conduct a test to see which color the buyers liked the best. They made 8,100 gram candy bars and wrapped 2,000 in red wrappers, 2,000 in blue wrappers, 2,000 in green wrappers, 2,000 in brown wrappers, and all of the bars sold for 75 cents, had the same shape and placed in the same store display. And at the right, you see the data for how many were sold. In this experiment, what is the independent variable in this experiment? What is the independent variable? Yeah?
Color of wrappers.
The color of the wrappers. That was what was different between these groups. The color of the wrappers. What was the dependent variable in their experiment? Donovan?
What color wrapper would perform the best?
What exactly what data were they collecting that would tell them that?
The amount sold.
Yeah, the amount sold. What you gave me was more of the problem. You know, they want to know which one would sell the best. But the data they actually collected was how many were sold. Right. Variables they held constant. Olivia, what's one? The shape of the candy bar? Yes. Okay. Caitlin?
The cost.
The cost. They all have the same cost. Yes. Matt?
Sold at the same store.
They're sold at the same store. Another one. Thomas?
The same amount.
Same amount of what?
Candy bars.
That they made?
Yeah.
Okay, yep. All right, good. Any questions about those questions? So you should be able to read about an experiment,